In Q2, Company Z deployed a conversational AI bot, and the executive dashboard immediately lit up green. They reached a 60% bot containment rate while maintaining a stable 84% agent occupancy. On the contact center floor, customer satisfaction plummeted as the operation buckled under the weight of an unmanageable queue. The breaking point arrived on a Friday afternoon. Despite a highly confident AI forecast predicting a quiet shift, the queue surged to 400% of capacity. Planners often assume AI bots act as a simple volume filter. The common approach is to take standard Erlang formulas, reduce the inputs, and run the math exactly as before. This collapse occurred because the underlying workforce management math never accounted for how the bot transformed the remaining workload, even as technical containment targets were met. AI institutionalizes historical errors and distorts traditional operational formulas at scale, surfacing structural mathematical flaws that were previously hidden. AI forecasting models operate strictly on pattern matching. They ingest historical volume and identify recurring trends, but they lack the capability for contextual or causal reasoning. This chart tracks Zed's historical contact volume over 3 years, showing sharp, identical anomalies spiking every February. To the machine, this is natural seasonality. These spikes were actually triggered by a recurring 30-day billing delay error that caused immediate customer panic. Even after the billing bug was permanently fixed, the AI model evaluated the historical data and confidently predicted the exact same volume surge for year 4. The contact center is now securing budget and overstaffing to prepare for a ghost, an operational failure that no longer exists. This introduces automation bias. When an algorithm consistently displays a 97% confidence score, planners frequently stop interrogating the output. We saw the result of this bias during Zed's Friday collapse, when a novel billing error went viral on social media at noon. Confident in its historical pattern of quiet Friday afternoons, the AI completely failed to adapt to the resulting 400% volume surge. A mathematically sound forecast can remain blind to context. Without human analysts interrogating the data, the model turns unexamined historical scars into guaranteed future liabilities. Legacy operations relied on silos, where voice, email, and chat each had discrete queues. Today's hybrid environment is fluid. The journey model recognizes that a single customer issue now routinely initiates as a voice call, deflects into a chatbot session, and finally escalates into an email callback. Analyzing 10,000 resolved contacts at Zed revealed that 34% of customer paths touched more than one channel before reaching a final resolution. The workforce engine was still calculating capacity, as if it were receiving 10,000 discrete, single-channel demands. In reality, the floor was servicing 10,000 fragmented journeys. Each journey generated multiple demands across different channels, with highly variable escalation probabilities. Omnichannel automation necessitates a shift from channel-based planning to journey-based modeling. Counting single channels creates a structural blind spot that leaves escalation queues understaffed. The traditional occupancy formula compares active handling time to total logged-in time. It often produces healthy metrics that obscure the reality of agent burnout. Because bots now filter out simple, transactional interactions, the volume reaching human agents consists almost entirely of complex or emotionally charged issues. This reality requires a new metric, the escalation load index. This index accounts for the time required for an agent to process failed bot conversation logs and the labor needed to de-escalate a frustrated user. Zed's data showed that agents handling direct contacts had a 3.2% error rate. For contacts escalated from a bot, that error rate spiked to 8.7%. Consequently, the average handle time for a bot-escalated contact is consistently 40% higher than a direct inquiry. This extra handling effort and cognitive recovery time represent a massive category of shrinkage that legacy software ignores. Without introducing this bot failure overhead into shrinkage calculations, a standard 84% occupancy target will run human agents into the ground. Deploying an expensive AI tool on top of unadjusted operational mathematics merely generates the wrong operational answers with higher velocity. The real-time analyst role has evolved beyond wallboard monitoring, as bots now handle the bulk of standard queue movement. Modern analysts interrogate AI outputs, track escalation velocity, and override anomalies in real time. Workforce management must also claim a primary seat in the design of the organization's AI roadmap. At Z, a routing logic configured solely for the shortest queue time inadvertently dumped complex escalations onto underskilled agents, a risk WFM data could have prevented. Augmented intelligence requires a specific architecture, a base layer of clean data and journey-based math, an AI acceleration layer, and human governance gating the final output. Building a precise human algorithm is the prerequisite for modern operations. Only then can the machine safely follow as a controlled accelerator.